We hear a lot about climate change, but how does climate change work? One of the main components of climate change is a greenhouse effect. That is what we are going to look at today. To understand the basics of the greenhouse effect, we need to understand the following: where our heat comes from, how heat is trapped by our atmosphere, and why CO2 traps more heat. Almost all our heat comes from the sun. This heat is transported as energy by rays of light. It's something we all have felt when bathing in the light of a warm and sunny day. The light rays consist of a lot of different light particles that we call photons. You already know these photons as the different colors that you see. A photon with a lot of energy you see as blue light. A photon with less energy you see as red light. There are even photons that you can't see, like infrared or ultraviolet light. The sun sends out an enormous amount of photons with a lot of different energies. We call the amount of photons that the sun produces of every energy the spectrum of the sun. The spectrum, and therefore the amount of light produced, depends on the temperature of the sun. Once the light of the sun reaches our planet, it has to go through our atmosphere. This atmosphere consists of a lot of atoms and molecules. These atoms and molecules can block incoming light. You probably know already that the molecule ozone blocks UV rays. So a fraction of the sunlight is blocked by the atmosphere. Most of the sunlight, however, can travel through the atmosphere unscathed. This light reaches the ground and heats up our nice little planet, which makes us happy because we need a bit of heat to live. The sun emits light because it's hot, but also things that are colder will emit light. So the light that heats our planet also ensures that the Earth emits light. You won't see this light, however, because it's mostly infrared light. Remember how most of the sunlight could go straight through our atmosphere? Well, for the light emitted by the Earth, this is another story. And this is the crucial part of this video. All the atoms and molecules in our air can block light, and some are particularly good at blocking the light that our planet tries to send to space. So how does this work? When the Earth emits a photon, the photon has a chance to encounter an atom or molecule that can absorb this light particle. After a short while, the photon is re-emitted in a random direction. So when this happens to be downwards, the light is effectively blocked from leaving this planet, trapping the heat in the process. The Earth only loses heat by sending light into space, and since the sun doesn't stop shining, our Earth will heat up like an oven if it cannot get rid of its heat. Now the question of course is why CO2 is so dangerous. There's a lot of air, so how does our emission of this gas change anything? The thing is that every atom and molecule is good at absorbing light with specific energies. So an atom that's good at absorbing yellow light is not necessarily good at absorbing infrared light. CO2 is one of the molecules that absorb just the right kind of light in order to prevent our planet from losing all the excess heat. CO2 isn't even the strongest greenhouse gas out there. There are gases that are thousands of times more powerful. It's only because we produce so enormously much of it that the fragile balance that keeps our planet at the right temperature for us is being disturbed. It is of vital importance for our survival that we overcome this problem. Hopefully, through the combined efforts of governments, companies, researchers and you, we will succeed.